Welcome to the quiz for Competency 7. In this video, we will work with the pre-calculus elements of middle school mathematics. Number 1, given the series 1 minus a half minus a fourth minus an eighth on to infinity, to what value will the series converge or diverge? Okay, there's a little trick or ways to see this particular series. Okay, now we do know that the first value 1 is 1 over 1. Okay, and then as we look at the rest of them, we can see this. Okay, we can see that this implies that we have 1 over n. And most people don't think about the fact that 1 equals 1 over 1. And then you see that n is increasing. So as n approaches infinity, it increases. Okay. Now, this gives us, kind of a pretty layman way to look at it. And we can put it in the calculator. But before we do all that and look at it in that manner, let's look at it another way. Let's say that we're going to put parentheses around all of the fractions that are being subtracted. But when we do this, we have to rewrite. Be careful. So really, we have 1 minus, and then in parentheses, we're pulling out that negative 1. So I'm going to pull out the negative 1 so you can see it. And then we have a half plus the fourth plus an eighth and so on. Okay, that being said, all right, what we're seeing is that we have a half plus, and you just keep adding them and adding them. So what we're going to call this in parentheses is our inner sum. So we're taking a series out of a series, and we're letting the one kind of hang on for the right, okay? All right, so let's use that infinite sum formula. Okay, so we have S equals, now if we're only going to look at the inside, then A is a half, okay, and that would be over 1 minus a half, and obviously that will be half over half, and then that's going to be 1. So what we're saying is this sum equals 1. Now, if we take that sum, we go back to it and we're like, okay, well, what would that actually make the entire series equal? Okay, remember, this is that inner. So I'm going to call that S of 1. Give it a notation so you see that this is only the sum of what's inside. We factored it out. Now that we have factored that out, what do we honestly have? That means our series, our original series, that is infinite, actually equals 1 minus 1, which would converge to 0. Now, let's look at it logically. Okay, that's just one nice way to look at that. Okay, all right, so first off, let's see A, B, C, D. A, get rid of it. C, get rid of it. Obviously, it's not going to diverge and just get infinitely larger or diverge off somewhere. Okay, so we know it converges. Well, we know that D is correct because that's just logical. You take one and you keep subtracting, smaller and smaller bits off of it, little bits. You're going to get close to 0, but never reach it. So it's going to converge towards 0 as n increases. That's kind of what I've been leading up to here. So we know that B is not correct. Well, we could also see that in our calculator here, this little calculator. I've already stated here that really what we have is a series of 1 over n, where 1 being 1 over 1, when we start with the number 1. Okay, and we just go on and they get larger and larger. So let's put that in the calculator and test it. So go to your table. All right, so n will have to equal x in our calculator. I have it set up. Well, let's look at what's going to happen. All right, I'm going to start at 0 for a reason, and I want to show you the table. I'm not going to use ask x yet. Okay, then enter and enter. Okay, look, 0 has an error. So what that's telling me, like the other problems where we had an asymptote that something isn't reached, well, that's telling me this may be kind of the same situation. So what we have is we have this. We have a situation where it comes closer and closer as we go to infinity if we're looking at the positive. But what if we're looking at the negative? Okay, this means if we go the negative direction. So we're never going to hit 0, which is essentially, x's. Okay. All right. So if x is 0 or n is 0, it is going to be undefined. Well, that explains a whole lot. And as we go up, look at how we're just going further and further and further towards negative infinity. That's if our x value or n in the denominator is getting larger. Now go the other direction. Let's say it's a positive denominator, its value, and it's just getting larger and larger and larger. Okay, well, and if you want to see, if you don't remember from other videos, you want to see what that fraction looks like in a decimal, just highlight it, arrow over, and push your toggle button, and see, it gives us a value that's closer and closer. Well, that's one way to test it, but that's tedious because it looks kind of like it, but am I sure? Well, just go use Ask X. So clear this out, clear back, and then go over to Ask X. See, I have it highlighted. Enter until you see it. Now, I have a very large number in there. This was from a prior testing. I just put a 1 in and a bunch of zeros. You can put more in. Look at how close to 0 is. Therefore, it is proven with our little simple calculator. Okay. Also, just a little bit of logic. Okay. Now let's look at number 2. Number 2, what is the solution of the limit as x approaches infinity for the function a half to the x exponent? Well, before we do anything, let's look at some preliminaries, all right? So we know that the function, this is a function they gave us, and we're looking for the limit of it, and we can rewrite that. So we have a half. I'm going to put it in parentheses so you see it a little clearer. Writing it this way makes it very obvious. This gives us a fraction where 1 is to the exponent of x and 2 is to the exponent of x. Simplify that. Well, 1 to any exponent is simply 1. And then our denominator of 2 to the x, we know as x approaches infinity that it's going to get larger. And the implication is that 2x approaches infinity will give us that same situation as 1 over n from the problem above. Okay, and I'm going to write that in from number 1. It's the same idea. That being said, we know that its limit is 1 and it's going to look almost the same. Okay, so D is a reasonable option. Okay, but let's put that in the calculator and see what we get. So use your table function again. I have it set up, and let's start at 0. Let's take a look at this and see what happens. Okay, remember, we're only looking at as x approaches infinity. This means that x needs to be that positive value. Okay, so let's go 0 and increase to infinity. Okay. Oh, there it is. Eventually, we don't have fractions anymore because there isn't a reasonable fraction. Now look at what happens to our decimals. It's just getting closer and closer to 1. that again, our calculator can kind of prove the logic for us, which it has. All right, let's look at number 3. Okay, now, what is the average rate of change for the function f of x equals x squared minus 3x plus 2 over the interval 2 to 6? Now, we did this in another video. It should look familiar, but average rate of change is AKA slope, okay? And our slope formula, the minute we see an interval, we should know that we are going to work with a slope formula. We can use our calculator, okay? And we know we have 6 minus 2 because those are our x values and we subtract the x's in our denominator. Okay, now let's go second mode, table, clear it all out, and put in our new function we have here, our given. So x squared minus 3x plus 2. Push enter, start at 6. Okay. Actually, let's start at 0, but we're not going to even do that. We are going to use the ask function. So enter to highlight it. Now let's go to OK and go. Okay. We have something else in here. This is from another question. So what do we do here? We delete out each of those, go back up, because we only have 3 spaces and it'll keep typing over, but we only need 2. So push 6, enter. Okay, so that's our first guy. Okay, that's 1, 2. Oh, let's go back and make sure we entered that correctly because that doesn't look familiar to me. Oh, look at what I did. Oh, you probably saw me do that. So let's push clear. X squared. Okay, minus 3x plus 2. Enter, 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 enter. Okay, that looks better. Oh my gosh, I was going too fast and I didn't verify what I was typing in. Bad situation. Well, I guess I would have found out when none of my options worked. Okay, so let's go ahead and clear out all this stuff we have here. You can rewind the video if you need to see this. Okay, so now let me fix this. What do we need here? We need 20. Now go down and we enter 2. And that's minus 0. Okay. So you already see what that is. That is 20 over 4, which equals 5. But just in case that's larger numbers or I did something else crazy, let me make sure. Set up my fraction, 20 minus 0, go down, 6 minus 2, and it is 5. So option D, verified. Okay, and I'm so sorry, everybody, that I typed that in incorrectly. I'll go back. Yes, verify before we move on. Yes, that is entered correctly. Thank you for your patience. I'm sure when I was typing that in, you probably thought, well, what is wrong? What is she doing? That doesn't make sense. You're right. It did not make sense. But this is why we should always double check. So let's go to number 4. Number 4, use the table of values to find the average rate of change over the interval 2 to 3.5. So we're using this. And remember that we have y as our numerator, okay? And we start at the second. Well, actually, what we need is consistency. Regardless of which of these you start with, you have to be consistent from one to the next. Okay, so let's set up our fraction. So we're going to start with our y's, and I want to start with 15 and subtract 25 over 3.5 minus 2, enter, and that suspiciously but correctly is it's a negative with a 6 repeating. Okay? Honestly, I would have never guessed that. Okay. So, anyway, let's move on to next one. Okay. Use the graph of the curve below to answer the following questions. Each line is said to be tangent to the given curve. And remember, that is very important because number 5 is asking, what is the change of y over the change of x of the line at point A? And this is checking because that's tangent. This is like a pre-algebra thing. What is the instantaneous rate of change? Okay. All right. So let's take a look at that. Okay. So we are dealing with our slope, but what are we really looking at? Well, this is what I'm seeing. If I'm going to look at the slope of that tangent line, I see -2 over, sorry about that. Okay, kind of like having trouble drawing here. 1, 2 over 2. I see -1, which would be option B. Okay, this is kind of another thing that you want to look at. You want to look at this line, another way to see it. Well, I see y equals 1 minus x. That means m equals -1. So there's two ways to view this. The slope of the line with rise over run, or the slope of the line in the equation given to us. Okay? Right. Either way, we had it correct, right? And I wanted to show you it was here. It looks better in a highlight. Okay, you can see what we did better. All right. And you see the line is going in the negative, it has a negative slope rather. Okay. All right. This is the last question in this video. Thank you for watching and putting up with me. Sorry about typing in the wrong thing. Not sure what I did there. Anyway, we all fixed it and now we know double check and double check. Thanks for watching, sharing, liking, and definitely thank you for subscribing. Happy testing.